not trying to be all hard, you.
So for this problem, we're going to look at the conservation of momentum in an elastic collision. So we have car 1. Car 1 has a mass of 500 and is traveling at 4 meters per second towards car 2, which has a mass of 300 and has a velocity of 5 meters per second. So automatically, I already know that they're traveling at about the same speed, but this one is a lot larger. So when they hit each other, I know that the whole thing is going to shift this way because this car is too small to have an effect on the direction of this car. All right, so after the collision, if the velocity of this car is now 2.3, so we see it slow from 4 meters per second to 2.3 meters per second, what is the velocity of the second car after the equation? So we'll first start with our givens and our unknowns. All right, so my given information, they gave me M1, V1, initial, and that's going to be 500, 4 meters per second. I know this is also going to be equal to M1 final. Then we got M2, V2 initial. This is 300, and this is 5 meters per second. I know the M2 final is also going to be the same. Then I know that V1 final is 2.3 meters per second. And then they're asking me to find the velocity of this car after the collision. So they want V2 final after the collision. So we have this equation, M1 V1, M2 V2 equals M1 V1, M2 V2 after the collision. So here, this is the equal sign. Momentum is always conserved. So the mass and velocity of car 1 plus the mass and velocity of car 2 is going to be equal to the mass and velocity of car 1 and 2 after the collision. So we'll rearrange this equation, and what we're going to get is V2 final. That's going to be equal to M1I, V1I, plus M2I, V2I, minus, because we want this term by itself, M1 final, V1 final, and then we'd have to divide off the M2, M2 final. And then from there, all we do is just substitute in. So now we're going to substitute in our variables from here. So I know M1 V1, 500 kilograms, times V1 is 4 meters per second, plus M2 V2, 300 kilograms, times 5 meters per second, minus M1 final, V1 final. So M1 final is 500 kilograms times V1 final 2.3. And then we divide that all by the second mass, mass 2 final, which is 300 kilograms. And then when we do all of that, when we do this math, we're going to get 7.8 meters per second. And then that'll be your final answer. Make sure you have your units, because if you don't have the units, we'll go ahead, that will be real quick.